This video tutorial will look at finding the greatest common factor, an essential skill when factoring a polynomial. Let's find the greatest common factor of 2x plus 6. To do this, we need to identify the terms within the polynomial and then determine what is the greatest common factor of those terms. In this polynomial, the two terms are 2x and positive 6. To find the greatest common factor, we have to determine the greatest common factor between 2 and 6, which is 2. Because both of the terms do not include x, 2 would be our greatest common factor. Let's take a look at another example, 8xy plus 28, and determine the greatest common factor. Again, to do this, we need to find the greatest common factor between the two terms. The first term is 8xy, and the second is positive 28. The greatest common factor of 8 and 28 is 4. This would be our greatest common factor because both of the terms do not have the variable x or y. Let's take a look at another, slightly more complex example. Let's determine the greatest common factor of 16xy minus 8x squared. Again, we need to determine the greatest common factor of the terms within the polynomial. The first term is 16xy, and the second term is negative 8x squared. We're going to break this example down differently than the previous two examples. Let's break 16xy down into expanded form. This would be 16 times x times y. Let's break negative 8x squared down to expanded form. This would be negative 8 times x times x. Now it will be a little bit easier to determine what these two terms have in common so that we can identify our greatest common factor. The greatest common factor of 16 and negative 8 is 8. Both terms have one x in common, and there is not a y in both terms, so there is no y in common. So we have determined that the greatest common factor of 16xy minus 8x squared is 8x. Let's look at another slightly more complex example. 4x squared y to the third z plus 22x squared y to the fourth z to the third. Let's start by writing our first term in expanded form. 4 times x times x times y times y times y times z. So 4x squared y to the third z in expanded form is 4 times x times y times y times y times z. Let's do the same for our second term, positive 22x squared y to the fourth z to the third. 22 times x times y times y times y times y times z times z times z. So 22 x squared y to the fourth z to the third in expanded form is 22 times x times y times y times y times y times z times z times z. Now that we have done this, let's see what the two terms have in common. 4 and 22, the greatest common factor would be 2. Both have two x's, so that would be x squared. Both have three y's in common, so that would be y to the third. And both have one z in common, so that would be z. So we have determined that the greatest common factor of the polynomial 4x squared y to the third z plus 22x squared y to the fourth z to the third is 2x squared y to the third z. Let's do another example, 3xy plus 6x squared minus 15xy squared. This is a three-term polynomial, unlike our previous examples which have been two-term polynomials. We will follow the same strategy and write each term in expanded form. 3xy would be 3 times x times y. Positive 6x squared would be 6 times x times x. And negative 15xy squared would be negative 15 times x times y times y. Now let's determine the greatest common factor. Between 3, 6, and negative 15, the greatest common factor is 3. each of the terms has one x in common, so that would be x, and all three terms do not have a y in it, so there is no y in common. So the greatest common factor of 3xy plus 6x squared minus 15xy squared is 3x.